middle school math. We are going at it with lesson 10. And I apologize if there is any background noise. I'm having to go out of town. So, guess where I'm at? I am recording this at LaGuardia Airport. Hey, can't stop, won't stop. The grind never will stop. Okay, so today we are continuing working with number lines. Go back to video for lesson 9 and look at the number line that we did for that. We did 30 times 2. That's where we began. We began with 30 times 2, and then we did 30 times 20, and then 30 times 2 tenths. And we were talking about how each time you go down, you are decreasing your place value by 1. And it was also a great opportunity for us to practice working with multiplying decimals. We did a lot of multiplication and a few division with multiplying with decimals. But let's look at a new number string. We begin with 14 times 3. Now down here, I have the steps for multiplying decimals. You have scale up to a friendly place value, multiply, and then scale down. So oh, didn't mean to do that. Let's do 14 times 3, and I'm going to do that over here using the standard algorithm. So 3 times 4 equals 12. I'm going to put the 2 there and the 1 up here. I'm going to put the 1 in the added. Now I'm going to do 3 times 1, which is 3, and I'm going to add that 1, and I get 42. So if I just wanted to do 14 plus 14, 8, 2, one more 14, and look at that, it checks out. So we did a good job on that one. And let's go over here, do 42. Now remember, this is our factor 1 and factor 2. When you multiply those, you get a product, the answer. Those were vocab words from Unit 1. So look, factor 1 is the same in A, B, C, D, E, and F. The only part that's changing is factor 2. So let's look. From A to B, we see that factor 2 is increasing by 10, 1 place value. So our product is going to do the same thing. Our product is going to go from 42, and our place value is going to increase. Put that right there. Again, I apologize for the background noise. There's a lot of people talking around me, but hey, we got to stay focused. If I can film in an airport, you can watch me film in an airport. So here we go. 42 then becomes 420. It also increased 1 place value. Okay, well then let's look at if we go from, let's forget about B. Let me, okay, there we go. Let's forget about B. Let's focus on A to C. So when I go from A to C, it's going from 3 to 3/10. That is decreasing 1 place value. And you know that my product is going to do the same thing. So if factor 1 goes from 3 to 3/10, that's dividing by 10. So my product is going to do the same thing, divide by 10. So 42, here's the decimal. When I divide by 10, I'm not going to move it behind the 0 because that would increase my place value. I am decreasing my place value. So I'm dividing by 10. So it's going to become 4 and 2/10. So when we go, let's do this. Every single time now, we are just decreasing one place value. So this is going to be 42 hundredths. I decrease another place value from 3 hundredths to, oh, wait, check yourself, y'all. Check yourself. I got in a habit. I almost didn't even catch that we have this right here. Look at that. 14 now became 1 and 4/10. What happened between 14 to make it 1 and 4/10? What operation would we use? To make 14 into 1/10, you would have divided by 10. You would have decreased it one place value. Because 14, we divide it by 10, that decimal point goes right here. And we can see that 3 hundredths stayed the same. That did not change. So let's look at this though. Let's see what we would do. So 3/10 to 3 hundredths, we divided by 10. So now that is going to become 42 hundredths. Well, 3 from D to E, 3 hundredths stayed the same. That didn't decrease. But 14 decreased one place value. So our product is going to decrease one place value as well, becoming 42 thousandths. I want to use this last one as an opportunity to practice the steps for multiplying decimals. So I want 14 thousandths to become a friendly place value. How much would I have to scale up to make it a friendly place value? It would be 1, 2, 3. I would need to multiply that by 1,000. And to make 3 a friendly place value, I would need to make it times 1, so times 10. So now I have 14 times 3. And as we said up here, that's 42. Do an array, do standard algorithm, do whatever you are comfortable with. So I have 42 now. But the last step is that I need to scale down to the original place value. Okay, so if I am scaling down, first, let's do 1,000. So I multiply by 1,000 first. So now I'm going to divide by 1,000. When I do that, it becomes 1, 2, 3. And my new product is, let me change my colors there. All right. So I did divide by 1,000. Now I need to divide by 10 because I did that over here. So I'm just going to move that place value once. And our final answer is, boom. That is how we multiply decimals. Scale up, multiply, and scale back down. Do the opposite. The opposite of multiplication, division. Practice multiplying our decimals. Remember, we multiply up, multiply, scale back down. I'm sorry. We scale up to a friendly place value, multiply, and then we scale back down. That is how we complete multiplying with decimals. I hope y'all can hear me okay. I'm sorry if it's quiet. Okay, so now we're going into lesson 7, continuing with multiplying with decimals. But before we do that, there is a fun activity here that I enjoyed immensely. Okay, so letters A, B, C, and D each represent a digit from 0 to 9. Find a set of values for A, B, C, and D that satisfy the conditions below. So we are given the final answer. We are given that the final answer is 13 and 148 thousandths. But we are trying to solve, how can we figure it out? How can we figure it out? How is that possible? So we need to figure out, what does A equal, what does B equal, C equal, and D equal. So see if you can solve this on your own and then start the video when you're ready. So the first clue that we see and we need to begin with is actually a clue that we don't see. We don't see it. And that is this 0. Since there's not a number there, we are going to reveal that 0. So 0 minus C equals 8. You cannot subtract anything from 0 without getting a negative number. So whatever is in D, we are going to be borrowing from it. So I'm going to minus 1 and put that 1 right here. So 10 minus C equals 8. So that tells me that C is 2, because 10 minus 2 equals 8. That is one clue we just solved for. Okay, so that makes that, okay. What is the best next one that we can solve for? Well, another clue that we don't see but is there would be this one. That 0 is there. So we have A minus 0 equals 1. Anything minus 0 is itself. So we know A is 1. And so there's another A right here in 1. And that checks out with what we have so far. Look at that. 2 minus 1 equals 1. That's exactly what the problem is showing. So we checked our work and we are good. So let's move on to the next slide to make it neater. We did it. 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 Okay. So what number can we solve for now? Well, I'm going to say what we did over here with A, because anything minus 0 is itself. I think we should do with B. B minus 0 equals 3. So that tells me that B is 3. B is 3. B is 3. Yep. All right. Now we are on the last clue. The last one we have to solve for is D. So D minus 3 equals 4. And y'all, I'm not going to lie. First time I did this, I got so excited. I was like, that is easy. That is going to be 7, because 7 minus 3 equals 4. And I went for it. I said D is 7. That was my answer, and I was confident. But then I had a friend, Miss Garcia. She put me back in my place. She told me, Miss Tharp, that is not correct, because look, we borrowed We borrowed from D to make that 0 into a 10. Remember? We took 1 from that D. So now it is a 7, but it was originally an 8. D was 8, and we took from it. We were like, hey, we're going to borrow a 1 so that we can make it 10. So now it's 7, but originally D was 8. I just like that plot twist at the end that made you think twice about everything. All right, now we're going to be going on to celebrity exercises, their weight, and how much calories they burn. So, when you exercise, the number of calories you burn depends on two things: the type of exercise and your weight. Playing basketball for 1 minute burns 63,000 calories for every pound of body weight. Y'all, this is an important detail that we need to make sure we do not forget. Playing basketball for 1 minute burns 63 thousandths of a calorie for every pound of body weight. So the more pounds of body weight you have, the more calories you are going to burn each minute. Write that in your notes. The more body weight you have, the heavier you are, the more weight you are going to burn per minute. So let's do that for Selena Gomez first, and we'll work our way down. So we know 1 minute of basketball. Let's figure out for 1 minute of basketball how much each celebrity would burn. So Selena Gomez, she weighs 125 pounds. 100, wait, I want to use my black. 125 pounds times, and we're going to multiply it by the rate, 63 thousandths. So there we go. So what we are going to do, remember our steps: scale up, multiply, and then scale back down. So I want to get 63 thousandths to a friendly place value. So 1, 2, 3. I would multiply that by 1,000 because 1, 2, 3. Okay, now that is going to make it 125 times 63. You can do an array. You can do standard algorithm. I'm going to do standard algorithm just so we get practice. 5 times 3, 15. I'm going to put the 1 in the add it. 3 times 2, 6, plus 1, 7. 3 times 1, 3. All right, now we're going on to the tens place. 6 times 5, 30. I'm going to put that 3 in the add it. 6 times 2 is 12, plus 3 equals 15. I'm going to put that 1 in the add it. 6 times 1, 6, plus 1, 7. I'm going to add those values together. Sorry, I'm going on Selena's face. No disrespect, Selena. Okay, I got 700 or 7,875. 7,875. Okay, am I done? Am I done with this? We scaled up, we multiplied, and now I have 7,875. Now we need to scale down. I'm going to divide by 1,000. So that decimal point is going to move from here to 1, 2, oh, wrong color. Here's the decimal point. It is going to move 1, 2, 3. And Selena Gomez, in 1 minute of basketball, burned 875 thousandths calories. 875 thousandths calories. Now, I want y'all to pause the video and do the same thing for Justin Timberlake. Let's look at his weight. He weighs 160 pounds. So y'all need to multiply 100. Oh, I'm not in. Excuse me. 160 times the rate, which was 63 thousandths. Multiply these, and when you are done, start the video. We are doing 1 minute of basketball. How many calories would that burn? We are multiplying. Remember, we scale up to a friendly place value. Multiply. Scale down to the original place value. So I'm going to do 1, 2, 3. I'm multiplying that by 1,000 to make it 160 times 63. When I multiply that, you do an array, you do standard algorithm. I'm not going to waste your time. We get 10,080. I now need to scale that back 1,000. When I scale that back 1,000, 1, 2, 3, I get 10 and 800ths of a calories. So Justin Timberlake burned 10 and 800ths of calories in 1 minute of basketball. Notice he burned more than Selena. Selena only burned 7 and he burned 10. Why is that? That is because he weighs more. The more you weigh, the more calories you are going to burn per minute. They are playing the same amount of basketball. The only thing that's different, the only variable that is changing between these two is their weight. Again, I apologize for the background noise, scholars. I'm chilling in LaGuardia Airport until my flight takes off. Yes, I am that person that gets to the airport 2 to 3 hours before. I'm not trying to waste that much money on a plane ticket. Okay, I want to do now walking for Abby Wambach and LeBron James. So let's do 1 minute of walking. So 1 minute of walking burns 19 thousandths of a calorie for every pound. So we are going to multiply Abby's weight with the rate. So 19 thousandths of a calorie for every pound, and that's for 1 minute of walking. So let's go over here and multiply 19 thousandths multiplied by what was her weight? Her weight was 178. 178. Scholars, what am I going to do? I need to multiply up to a friendly place value. But which number am I going to multiply up? 178, that's already at a friendly place value. We're good. But 19 thousandths, that is not a friendly place value. So let's multiply that up. 1, 2, 3. I'm going to multiply it by 1,000 to get it to a friendly place value. Now it is 19 times 178. Again, scholars, I'm not wasting your time on doing standard algorithm or the array because you know how to do that. Show your work on your homework. If you do not show your work, it's a 0. No work, no credit. Y'all know the drill. So 3,382. Am I done? Nope. We need to scale down to the original place value. So we are going to divide by 1,000. 1, 2, 3. And Abby Wambach burned 3 calories, 382 thousandths of a calorie for walking 1 minute. That was for 1 minute of walking Abby Wambach burned 3 and 382 thousandths, 382 thousandths of a calorie while walking for 1 minute. Who do you think is going to burn more? Her or LeBron James, who had 250? Let's see. I want y'all to do this one on your own, and when you are ready, start the video. All right. I hope y'all did it and did it well, showing your work. Do what you got to do. So we are doing the rate. We are using 19 thousandths for every pound. So every minute that you walk, you burn 19 thousandths of a calorie for every pound you have. So 19 thousandths times 250. I am going to scale 19 thousandths up to make it a friendly place value, make it easy to multiply. I multiply by 1,000 because one place value, two place value, three place value. Let's do it again. If I multiply by 1,000, I'm going to go 1, 2, 3, and I get 19 times 250, which equals, you need to show your work on your homework, on your exit ticket. No work, no credit. 4,750. Am I done? Y'all know the drill. You're never done. I'm going to divide by 1,000 because I multiplied by 1,000 up here. I increased three place values. Now I'm going to put it back in the original place value. So 1, 2, 3. LeBron James burned. If he went walking for 1 minute, he would burn 4 calories, 750 thousandths of a calorie for walking 1 minute. Why did he burn more than Abby Wambach? They walked the same distance. They walked the same speed. The only thing that was different, the only thing that changed was the weight. LeBron James weighs more, so he is going to burn more. Because look, our rate, 1 minute of walking, you burn 19 thousandths of a calorie for every single pound. So we multiply your weight by the rate. We do rate multiplied. That's an ugly multiplication sign. Weight. All right. Great job, scholars. We would do the same thing for soccer. I'm going to show y'all each different slide. Pause it and take notes. Okay, this question is now asking us how much would he burn if he played 5 minutes. Y'all, let's be logical. We just solved for how much he would burn if he played 1 minute. So what would we need to do? We would need to multiply the amount that he burned in 1 minute, 10 and 800ths, and multiply that by 5, because that would be 5 minutes. So we multiply 10 and 800ths by 5 because he's playing 5 minutes and he burns 10 calories and 800ths in 1 minute. Our answer is going to be 50 and 4/10. But let's practice our multiplication. 10 and 800ths multiply by 5. I need to scale 10 and 800ths up to a friendly number. 1, 2, I'm going to multiply that by 100. Now I am multiplying 1,008 times 5. Show your work. And I get 5,040. I am not done. I need to divide by 100 because we multiply by 100 up there. 1, 2. And our final answer is plain Justin Timberlake burned 50 calories and 40 and 4 tenths playing 5 minutes of basketball. All right. Here are some more practice problems. So, how much would Selena Gomez burn if she did 1 minute of soccer? Do this on your own and start the video when you're ready for the answer. See if you got it correct. So, the new question is asking without doing math, how can we solve for how much LeBron James burned playing 1 minute of soccer? So we know that Selena Gomez weighs 125 pounds. In 1 minute of soccer, she burned 9.5 calories. All we, without even doing math, I know that LeBron James, he would burn 19 calories. How do I know that? Well, let's look at this. Her weight is 125. LeBron James, his weight is 250. That is twice as much. You would multiply that by 2. Multiply that by 2. So we would do the same with her calories. 1 minute playing, we would multiply that by 2 because he weighs twice as much. And that would be 19 calories. Remember, y'all, don't reinvent the wheel. Don't do a lot of work over. Let's play smart. Play chess, not checkers. Okay, this is our last and final problem. And it's about the Queen Bee, Miss Beyonce. We are going to be figuring out. So, every 5 yards that Beyonce runs, she burns 35 hundredths of a calorie. How many calories would she burn if she ran 2 miles? So, let's get our game plan going. What do we know? We know that Beyonce burns 35 hundredths of 1 calorie for every 5 yards. And then we know that she is going to run 2 miles. Finally, we are told that 1 mile is 1,760 yards. So, what is our game plan? Well, first, we need to figure out how many 5 yard segments are in 1,760 yards because that would tell us how many 5 yard segments are in 1 mile. Then we would simply double that. Double that to get 2 miles. So once we get how many 5 yard segments are in 1 mile, we are going to multiply that by 5-yard segments in 1 mile times 35 hundredths calories. Once we do that, finally, we would double. Because she ran, she's going to run 2 miles. We are going to double that because 1 plus 1 equals 2. I went there. I went there because I knew if I went there, you would get an A on the test. So it's worth it. I did that in the middle of LaGuardia Airport. Don't say I don't care. Okay. So what we need to do is divide. We are beginning by dividing 1,760 divided by 5. I am going to show you the method that we did in Unit 1B. Y'all are capable of it. You don't need to master it yet. Get used to it, get comfortable with it because this is your future. You can multiply up. Do what you need to do. Divided by 5. Okay. So let me get where are my shapes? There we go. Okay. 5 times 3 equals 15. 5 times 30 equals 150. 5 times 300 would equal 1,500. So let's do a group of 300. I'm going to do 1,500. When I subtract that, I get 260. Not bad. We're pretty close. Okay. So I'm at 260. 5 times 4 equals 20. 5 times 40 equals 200. So I'm going to do a group of 40, and that will get me 200. I now have 60. What's 60 divided by 5? Use your timetables. That is 12. Okay, now I'm going to add this up. That is going to be 352. Am I done with this problem? I am not. I am not done with this problem, not even close. 352. Now what I need to do is multiply 352 times 35 hundredths. So I'm going to, first let me black out this second question because we're not going to do it. We are focusing on one. Okay. And I'm going to show my work down here. So we are multiplying 352 times 35 hundredths. I need to get 35 hundredths to a friendly place value. 1, 2. I want to make it 35. So that's multiplied by 100. Now I am doing 352 times 35. Use standard algorithm. Use an array. Do what you got to do, but show your work. So that is going to be 12,320. I am not done yet. I need to now do the opposite of multiply by 100, and I divide by 100. So 1, 2, and that gets me. I need to change my color. 123.2, 123 and 2/10. Are we done? That's how many calories she would burn in 1 mile. Calories in 1 mile. Well, Queen Bee, remember, she is running 2 miles. So we need to double that because 1 mile plus 1 mile One, two, three. One, two, three. Because 1 plus 1 equals 2. Four never gets old. 6, 4. 200, 246 and 4 tenths calories for running 2 miles. You go, Beyonce. Good for you, girl. We need to make sure that we read the problem and figure out what is it asking, what do we know, and how do we solve that. All right, y'all. I have 3 minutes to get to my gate before I take off. So thank you for watching, and please watch more videos, review, get your practice. Remember what I said in class. The athletes that lift the most weight are the strongest. Lifting weight is not easy, but the harder the weight, the stronger you are. The more weight, the stronger you are. So lift your weights, do your homework, get your practice. It's supposed to be hard. All right, y'all. Have a great day and get ready for finals.